So today's date 3/16/18. All right. So anytime x is in the exponent, you can't solve for it in a normal way. You can't. So you've got to come up with some tricks. One of which is, of course, using logarithms. But in example 1, instead of logarithms, actually I can do something different. If I can change them to the same base, I can avoid using logarithms. Okay. What I can do is I can change 8 into 2 cubed, which would leave them the same base. So instead of writing 8, let's write 2 cubed, or 2 to the 3x, equals 2 to the x plus 6. Okay? If you can change them to the same base, then it becomes pretty easy. So if we know 2 to the 3x is equal to 2 to the x plus 6, then we can just set 3x equal to x plus 6. So what I wanted to do is make them the same base. I knew that 8 could be rewritten as 2 cubed, which gave them the same base, base 2, which then 2 to 3x would equal 2 to the x plus 6. Obviously, then the 3x would have to equal the x plus 6. And I'll just solve. Minus x. I'll get a 2x equals 6. Divide by 2, and x is equal to 3. Okay? That one's not too bad.
Wait.
Take a look.
If we subtract x from both sides. Oh, wait, never. Yeah.
It's all good, Claire. It's all good. Yep. All right, number 2. Again, if we can make them into the same base, we will, okay? So 27 is the same thing as 3 cubed, right? So instead of writing 27, let's just write 3 cubed. So I've got a 3 to the 2x plus 1 equals a 3 to the 3x. And then it kind of makes sense. We've got 3 to the 2x plus 1 equals 3 to 3x. Obviously, then 2x plus 1 would have to equal 3x, right? So we'll just go 2x plus 1 equals 3x. And we'll solve. Minus 2x, 1 equals 1x, or x equals 1. Okay? Not bad. So if you can make them into the same base, you don't have to use logarithms. Okay? You can just solve them. But if you cannot make them into the same base, we're going to have to use logarithms. Okay? In example 3, you cannot make 21 into some power base of 7. Now 3 times 7, but that's different. So you can't do this. So what you're going to have to do is what we learned yesterday. In order to bring the exponent down, I'm going to take the log of both sides. Okay? So I'm going to take the log of 7 to the negative x equals log of 21. Okay, now the log I use doesn't have a base. It's the invisible base, which we know is base 10. The reason we're going to use base 10 is because then I can use my calculator, right? So we want to keep it as the invisible base because base 10 is calculator base. Unless you have a fancy solely calculator. Renee's got a fancy calculator too, Renee. So from here we did that whole process so that we can float the exponent down. So the exponent comes down. We get a negative x log 7 equals log 21. I just need to solve for x. Log 7 is a number. It's a number in my calculator, okay? So I'm just going to treat it like a number. So I'm going to divide by log 7. Divide by log 7. And I'm going to have a negative x equals whatever that is. I'm just going to put that in my calculator. Okay? And that there you go. Don't make that log 21, you guys. Do not make that log 3. Do not make that log 3. Don't divide those because it's an ugly decimal divided by another ugly decimal. David just said it. I'm going to get it, David, because I didn't hear you, and I'm going to get it anyway because, you know, log 7. I bet you said 1.56. And then bring the negative over, right? So x would equal a negative 1.56. Okay. So before I move on, let me clarify. If you can make them the same base, base 2, then you can just solve it. If you can make them the same base 3, then you can just solve it. But if you cannot make them the same base, then what you're going to have to do is take the log of both sides to get the exponent down. When x is in the exponent, you've got to bring it down. The only way you can bring it down is by using a log rule. Okay? Let's look at number 4. Okay, number 4. Yes. Yes.
How'd you get rid of the 8 again for the first problem?
Oh, great. Okay, so right over here, did a little bit of work on the side. The number 8 is the same thing as 2 to the third power, isn't it?
Yeah.
And that's all I did. See, and let me circle. I never got rid of the 8. I just wrote it in a different form. Do you see my 8 right there? That is 8, isn't it? And that's what I did. And the same thing on the 27. I never really got rid of the 27. There's my 27 right there. See how I did it? Good question. Okay. All right, let's get down to number 4. Okay, now number 4 is different because there's no exponent. So what I'm going to do is use my log rule. I'm going to change this from log form to exponential form. I'll say it, and then I'll do it. I'm going to go 3 to the 2 power equals what's inside. So we're going to go 3 to the 2 power equals my x minus 5. Now it gets pretty easy, okay? Now, real quick warning, okay? Warning, warning, warning. This can never be 0, and this can never be negative. So if you get an answer that makes this 0 or negative, you're going to have to throw it out, okay? You can't have logs of 0. You can't have logs of negatives. So I'm going to write that up here real quickly, okay? So I get a 9 equals x minus 5, right? Add 5, and I get 14, okay? Now, let's do real quickly, make a little disclaimer here, way up in the side. Slide here, let's do a little note for ourselves. Log 0, undefined, log negative, undefined. Okay, can't happen, won't happen, right? We've talked about that before. You can't take the log of 0, and you can't take the log of a negative number. Okay, so if we get that in today's lesson, we throw those out. Okay, all right. It's my little.
Is that the symbol for undefined?
That's empty set, but
I thought that was if you wanted to write 0, but you had a lot of O's next to it, then you could do that.
no, mathematically that means the empty set. It really doesn't mean undefined, but you know I should write undefined. Undefined. How's that? It really is undefined. They're slightly different, Claire. Undefined. There you go. Yeah. Yeah. Well, it's a math thing. Okay. All right. Let's take a look at example 5. Now that we know that. So in example 5, I'm going to apply one of my log rules. And if it's subtract here, I'm going to bring the bases together as divide. So I'm going to go, okay, I'm going to rewrite this as log of 45x divided by 3 equals 1. Okay, so I just applied my log rule. Here's my divide. So in logarithms, if it's subtract, we can combine them as a division problem. Okay, now that's the same thing as log of 15x, right? So let's rewrite that as log of 15x equals 1. Now, there's an invisible base, right? And that's base 10, right? There's no invisible base, base 10. And I want to make sure I put it in there, because now I'm going to move it from log form to exponential form. So I'm going to go 10 to the 1 power, right? So we go 10 to the 1 power equals 15x. Now it's easy, right? Now it's easy. So I just went 10 to the 1 power equals 15x, or 10 equals 15x, right? Divide by 15, and what's that, 2/3, I think? Divide by 15, divide by 15, I think it's 2/3, okay? So far, so good? Okay, example 6. So before I do this problem, I'm going to float this 2 down. Because with logarithms, the reason we use logarithms is they allow us to bring the exponent down. That's the basic, the most important thing about logarithms. They help us bring the exponent down. So I'm going to rewrite this as 2 log base 4 of x equals 2. Okay.
You divide by 2.
Yeah, let's divide by 2. You guys agree with that? Divide by 2, divide by 2. Divide by 2, so I have log base 4 of x equals 1, right? Let's change it to exponential form. 4 to the 1 power equals x, right? 4 to the 1 power equals x. We'll go 4 to the 1 power equals x, or x equals 4. Okay? Not too bad. Okay, here comes the fun one. There's got to be at least one fun one in here. You ready for the fun one? So, I need to make it a single log. So I'm going to combine them. And when I see the plus sign here, I'm going to combine the two answers as multiply. So I'm going to rewrite this as log of x times x plus 9 equals 1. Okay? Because if I want to solve, I got to get down to a single log. Okay? There's an invisible base. What's my invisible base? 10. So we're going to go 10 to the 1 power equals what's inside, okay? 10 to the 1 power. So I'm going to go 10 to the 1 power equals x times x plus 9. Okay, now we're going to have to eventually factor. We'll eventually have to factor, okay? But let's check out why. We'll have a 10 equals x squared plus 9x, right? Let's bring over the 10, okay? 0 equals x squared plus 9x minus 10. Does that make sense? Bring over the 10, subtract 10. Subtract 10, bring it over there. Factor. What times what makes 10? We could do 2 and 5, but I like a 10 and a 1. I like an x plus 10 and an x minus 1. Okay? How's that look? Because that would make the positive 9 and negative 10. So if we do our mini equations, we've got x equals negative 10 and x equals positive 1. Except we're going to throw away the negative 10. Okay? Now I'll slide it back, but let's go back to that little thing. Okay? Logs can't be negative, right? Can't have a log of a negative number. So if I were to take the negative 10 and plug the negative 10 back into the original, okay? If I were to take this 10, plug this 10 right there, we'd have log of a negative 10, which you cannot do. You're going to get an error in your calculator. So we throw the negative 1 out, and you just get an answer of 1, okay? So you have to, what's that?
Is this kind of like what you did on the graph?
Mm-hmm. Yeah, it's totally right. Remember how the graph, AV, right? Remember the graph looked like this? Right? Remember how the graph looked like that? So there's no answers over here, are there? Remember that? There's no answers at negative 10, right? This is the graph for logarithm right here. 0 doesn't work, and neither do negatives. Very good observation. Okay? Okay, turn the page, but 1 would work. 1 is a value x on the graph, isn't it? Okay, turn the page. Okay, all right. So, let's do the same thing. But before we do anything, we're solving for x, right? I'm going to bring this 3, and I'm going to bring it back up and in, okay? It was an exponent. It was an exponent, so I'm going to float it back in and make it an exponent again, because I'm solving for x, right? So I'm going to rewrite this as 3 equals log of 8 plus log of x cubed, okay? It was an exponent that got floated out, but since I'm solving for x, I'm going to bring it back in as an x cubed equation, okay? Second thing I'm going to do is, because it's plus, I'm bringing them together and combine them as a single log, okay? So we'll go 3 equals log of 8x cubed. You okay with that step? Plus, and I brought them together as times. Now there's an itty-bitty times symbol here we never write, but we combine the 8 and the x cubed as times because we added the logs, okay? Now there's an invisible base. What's my invisible base? 10. Everybody agree? There's a base 10 there that we didn't write. It's an invisible base. So let's change it from log form to exponent form. We're going to go 10 to the third power. 10 to the third power equals what's inside, okay? So we're going to rewrite this as 10 to the third power equals 8x cubed, okay? How am I doing? Or 1,000 equals 8x cubed, okay? How am I doing? Divide by 8. Divide by 8. Now, if I leave this as 1,000 divided by 8, I could, because the cube root of that's going to give me a 10 over 2. You're probably not going to see that, so you're probably going to say, well, what is 1,000 divided by 8? And you're going to get 125. Okay, so you get 125 equals x cubed. And then we're just going to cube root it, right? Cube root cube root, and I get 5. Cube root of 125 is 5. Oh, these are fun. I told you it was one of my favorite days. Because I like to solve, I like to factor, and I like logarithms. And yes, I'm crazy. I know, right? So anyway.
It's okay, we're all crazy.
Yep, yep. I like math. I know that sounds really scary, but I like math. Okay, example 9. So if we're going to solve for x, let's bring this exponent back in. Okay, if we're going to solve for x, let's bring this exponent back in, okay? So let's rewrite this as log of x squared minus log of 4. 0. Okay, so that's how I did. First step, I just brought the exponent back in because I'm solving for x, right? I'm not trying to simplify it anymore, I'm trying to solve. Because it's a subtract, let's combine them as a divide. So let's rewrite as log of x squared divided by 4, okay? What's my hidden base? 10, right? Hidden base is 10. So let's go 10 to the 0 equals what's inside. We'll go 10 to the 0 power equals what's inside. So we'll go 10 to the 0 power equals x squared over 4. Anything 0 power is 1, right? So we've got 1 equals x squared over 4, right? Multiply by 4. Natalie, you got it. Yep. Yep. We've got 4 equals x squared, right? Square root, square root. Okay. Now, x is equal to, really, plus or minus 2, but no negative 2, right? No. We can't have the negative 2 because if you tried to take the log of a negative 2 way up here, you're going to get an error, right? So we get rid of that negative, get rid of that, and we're just going to have x equals positive 2. How's that? Okay, so it is Friday, but we have plenty of time to get this done, okay? So only 16 problems. 526, 2 through 20 or 32 even, okay?